everyone. Today we're going to be working on identifying polynomials. So the notes that I'm really giving you today are more of an explanation than really doing the process. There's a little bit of process to it, but you'll see as we get there. So the first step is really identifying what a polynomial is. So a polynomial is an expression with many terms. So just like what Miss Dwayne always does, she wants to break down the word. So poly means many, and then nomial is having to do with numbers or terms. So many terms, polynomial. Terms are part of a polynomial that is separated by pluses and subtraction signs. So any math sentence that you've seen in algebra usually is going to be a polynomial. So this example is 4x to the third power plus 5x plus 7x squared plus 9x to the fifth. This is going to be a polynomial. Now, terms are each and every one of these sections, and they're separated by addition and subtraction signs. So 4x to the third, that is one term. 5x is another one, 7x squared is another one, and 9x to the fifth is going to be another one. So this example has 4 terms. Our next example is 5x squared. That's it. There's no addition sign, no subtraction sign, so this is just a one-term example. Now, before you count the amount of terms, make sure that you combine like terms. The more terms, the more mistakes that can be made later. And you're also not going to properly identify the polynomial if you do not do this. So kind of just recapping how to combine like terms. What you want to find are variables and exponents that are the same. So you got your little cheat sheet down here. So my 3x squared, I put a square of orange around this, and I put an orange square around this one of plus x squared. So both of these have x squares with them. So that means that they can combine. This cannot combine with negative 5x because negative 5x does not have the same exponent as 5x. So negative 5x is its own color along with positive 2x. And then our plus 2 and minus 4 is another color because those two numbers do not have variables at all. Therefore, they can combine. Remember that when you are combining like terms, make sure that you include the sign in front because that tells you if the number is positive or negative. And when you're combining like terms, that is super important. So for example, negative 5x, if I didn't include that negative in there, this answer would be 7 instead of negative 3. So if I didn't do that, I would be wrong. So kind of jumping ahead of myself, what I did was I combined my 3x plus 1x. Since there's no number there, I can assume that it's a 1 to get 4x squared. I combined my negative 5x and positive 2x to get negative 3x, and my positive 2 and my negative 4 to get negative 2. And that creates a polynomial of 4x squared minus 3x minus 2. So remember, when combining like terms, make sure the variables and the powers are the same. Make sure to include the plus or minus sign in front of the number, and it should be written from the largest power to the smallest power. So my x squared is the largest power that I have, so that's going to be the first number that I include. Then I have an x, and then I have no x at all. So you always want to start from the largest power and go to the smallest power, and that is called standard form. This should all be review. If you need a reminder on how to do it, please go back into this notes website. So it's not just one thing of combining like terms. We actually have to name the polynomials, and there's 2 things that you need in order to name them. So they require the degree and the number of terms in the polynomial. So degree is the highest exponent. This should be the first term after combining like terms. So I have a polynomial right here. My highest degree, that biggest degree, is going to be that second power. So this is our example of last time. This degree is 2. So what we do is we find what that number is, and then we put a name to it. So degree names are terms that are used to express specific degrees. So if there's no degree on there at all, if it's just the number 6, we're going to call that a constant. If it has a degree of 1, it's going to be called linear. degree of 2, which is what ours is right up here. We have quadratic. 3 is cubic. 4 is Kartik. I apologize if I'm saying that incorrectly. And then any numbers 5 and above is going to be the number in the degree. So an example would be to 5th degree. So now that we have the degree name, we're going to also look at the term. So remember there's 2 parts to this, and I'll show some examples later, so hopefully it all comes together. So term names. The number of terms also have a name. Terms should be named after combining like terms. So remember, combining like terms is super, super important. So now the number of terms we have, if we have one term, that name is called a mononomial. So mono means one, and then we already talked about nomial being parts. So the binomial is 2. And then trinomial is 3. So if there's 3 terms, we call it a trinomial. 2 terms, we call it a binomial. And then 4 and above, we're going to call it a polynomial. So whether it's 4, 5, 6, 7, 8, 9, so on and so on, you call it a polynomial. If this is a little confusing, let's take a look at some examples. Okay, so I have 5 examples up here. When they ask you to identify what a polynomial is, again, you need 2 parts. So right now, for number 1, I have the number 6. There's no x by it, so we know we don't have a power. If we look back at our chart, we said that that's going to be a constant. So constant because there's no power to it. And then we have mononomial right there. It's a mononomial because it is only one term. There's only one box. It's not separated by addition or subtraction signs. So example number 1, our identifying of this polynomial is called a constant mononomial. Good. Let's take a look at the next one. So 2, we have 2x squared minus 1. So the first thing we want to look at is the degree. So we have a degree in this one, and that degree is 2. So only degree that we see on there, but it's also the largest, and that's really what we're looking for. So since it's a number of 2, we're going to call it a quadratic. Now looking at the terms, I have one subtraction sign in there, and then there are 2 terms surrounding it. So looking at the blue boxes, I have 1, 2. So that's 2 terms. And based on the chart from the previous page, that is called a binomial. So this polynomial right here is called a quadratic binomial. Whew, it's a big tongue-tied, but I know you're doing great. So 5x. 5x, x does have a power. And if you remember, just because it's not written there doesn't mean it doesn't exist. And that power is 1. Since that power is 1, we know it's going to be called linear, because that's what our chart said on the previous page. And then again, we only have one term. There's no addition or subtraction signs. It's only one thing. So we're going to call that a mononomial. Moving on, we have example 4. We have a power of 9. That's the highest degree that we're going to see here. So we're going to call it the 9th degree. Remember, anything above 5 is going to be the number in the degree. And then we have 3 parts. 1, 2, 3. And we're going to call that a trinomial. So this is a 9th degree trinomial. Oh, number 5, we have a doozy of a one. We have a lot of things in there. We have a power of 1, a power of 2, power of 3, and a power of 4. But remember, you only want the largest power. So we're going to take that 4, and we're going to put that term there that I messed up saying before. And then we're going to look at the number of terms that we have here. So we have 1, 2, 3, 4. 4 terms separated by addition and subtraction signs. Since it's 4, we're going to call it a polynomial. So we have this term right here for this polynomial right here. And then our last example, I really wanted to show you what the process is in order to get to that name if you have not combined like terms. So taking a look at this right up here, if I gave you this as an equation and you were told to find or to identify what it is, you will be able to find the largest power right away. That's fine. However, you are not able to tell me how many terms there are. So what you need to do is combine like terms. This negative 2x to the third power is in green. There's nothing else I can combine with it, so I just continued with it down. On this x squared, I have two x squareds. I have negative 6 and 4, combining those together to get negative 2x squared. And then I have 7x and negative 2x. Both of those have x's, so I'm going to combine those to get 5x. And then 2 and 3 combine to get 5. Now that I have everything in a polynomial, the standard form where it's supposed to be, with 3 as the largest power, going down to no power at all, I can see that my largest power is going to be 3. So that is called a cubic. And then I can see there are 4 terms. 1, 2, 3, 4. So that gives me polynomial. So this should be a cubic polynomial. So good luck. I know you can do this.